Somebody please time 5 minutes for inform.
How long is my presentation? According to the rules, we are given 10 minutes, right?
Yeah.
Yeah, so I expect to be 10 minutes.
10 minutes.
Or maybe shorter, 6 minutes. Today we are going to present to you our design innovation project. The topic we are doing is to design a solar dryer that can operate at night. And from here you can see that this picture shows our first concept sketch. So for the whole device, we have a frame, we have a drying chamber. There are three major units we have. A dryer, we call it a drying chamber, a control unit, and then a heat reservoir. That is at the early stage. That's our idea. This is considered one of our concept sketch. So this is our fundamental presentation where I'm going to talk today. I'm going to have an introduction about what drying is about and why is this so important to our society. Literature review of other solar dryers that we have in the market. How many types of solar dryers we have, design methods we have done, designing, prototype, testing methods. So according to SCD, or we also know as the United States Census Bureau, they have a population clock. So they will know that, they will calculate that the total population we have currently in the Earth. So they estimate that we have 7.161 billion number of people living in. So in the past, they are always talking about energy crisis and energy crisis. So it used to be a mystery, it used to be a question whether energy crisis is true or not. But now, after they have several studies, they found that energy crisis turning into something big and a big problem, a big issue that we're going to resolve in the future. If not, we cannot step into the 22nd century, which is also recognized by the National Academy of Engineering. They have set out a vote. They ask people to vote at what is the major thing you are going to do before you step into the 22nd century. And make solar energy economical is one of the major challenges in the list in 2014. So for our project, we will have do some calculation on the business value. Because without a business value, there's no point to make a product. So for this product, based on the energy needed for the dryer, and then followed by the price is followed by TMB, Malaysia standard. So in Malaysia, for agricultural product, they charge 30 ringgit, around 30 ringgit for every kilowatt. So we found that if we can have a tray dryer with this volume in this time, you can save around about 1 million. You can save around 1 million, which is a lot of money for the industry. Because in Malaysia, I can guarantee that every factory needs drying. Every factory, even not just industry, even for commercial, you need a dryer to dry your shoe. You need a dryer, you need an oven. Actually, oven is technically a dryer as well. It's one type of dryer. So you need an oven. Even in our lab, we have a Germany-made murmur dryer. So oven, we need it in every way, in every process. So I've done several literature review from the other books. From the first one, there's a paper from Elsevier. They have do a review to review all the solar dryer we have. Currently we have almost 10 to 11 types of solar dryer we have. And then the longest time duration for drying they record is 17 days. And then the shortest is 58 hours with dry grapes. This is starting on seedless grapes. And then the highest temperature range normally they have is 51.9 to 64.6 Celsius. And then the lowest is 20 to 45 Celsius. So the other paper, we try to study that with a PCM-based solar integrated dryer. PCM means phase change material. It's a very common material that they use for heat storage. They use it in heat storage, and then in Malaysia we have some companies selling PCM material as well, but they are using as a catalyst and agent, reaction agent. They use it for the other purpose, for example like rubbering, catalytic, this kind of thing. But actually in the other country, they already found that it has a great potential to use in thermal storage. So we found that drying time shortened when drying air velocity is increased. So and they concluded that we have a model which gave a best result for rapid drying. The third one, they have obtained an efficiency of 17.6% for solar dryer and 54% for the solar water heater. Okay, so this is the type of solar dryer we have in the market. It's using air, using a barn, using a chimney. This one is using forced convection type compound dryer. And the future and present use is for agricultural product drying, for all these space heating, desalination, wastewater treatment, cooking, electricity supply. And this is our design method. So we have followed several design methods. We follow the GIP design method, gather, ideated, and prototype. So this is the gather process. So we use an Ishikawa diagram, or we call it as a fishbone diagram, to do a testing to check that what caused the low efficiency of the solar dryer, what parameters, what thing will cause it. So we have come up with a fishbone diagram, and then this is our brainstorming section. So we come up with several ideas. This is our decision matrix. So we, based on the 4 criteria with the 5 improvement, we have concluded which one is the most important thing we should improve, which one we can just trim it up, take it up. So this is our final concept sketch, which now the thing you see now is followed by this sketch. So we have a solar water collector, we have a water tank, heat storage tank, we have a drying chamber, and then if it's needed, we have an option that you can add a electricity heater, which is powered by a PV solar panel. So this is the CAD computational aided diagram. This one is the equation we're going to use to find the drying time. From here, it mentioned about the dry bulb temperature and the wet bulb temperature, which we will be using the psychrometric chart. This psychrometric chart is given by the Carrier, which is one of the largest company which sell refrigeration from USA. So this is a dry efficiency equation used to define the efficiency used by the dryer. This is the solar collector efficiency. For us, it's the solar water collector. So from this equation, we can calculate the efficiency of the solar collector. So now we're going to talking about explain to you how is our prototype look like. So the dimension is 46.4 times 60 times 45.5 cm for the drying chamber, which is this one. And then the whole thing is constructed by using plywood. And we have battery power, 4 inches, 12 volts, brushless axial fan inside that to cause forced convection in order to recirculate the air from the bottom to the top. It is purchased from Malaysia. And then we have a 50 meter long copper coil with 9.5 mm diameter and 0.51 thickness, which is using as a heating element to let the water flow through. Normally in the market, if you are buying an electric oven, they will have a ceramic cover heating element. So for us, we're using water as our heat transfer agent. So we have a copper coil, and then the copper coil is followed by a manufacturer standard of ASTM 280. So for the tray, we also have a tray because this is a tray dryer. So our tray is 41.4 times 43.5 times 0.6 cm dimension with a PVC net to hold up the thing. So this is the whole thing look like. This is the mat, and this is the drying chamber. We have a heat, make a door. Okay, so this is the fan. And the other thing is the heat storage unit, which you saw is here. We are using a Schwarz SDS1. The model is SDS1, Germany made water tank, which they have tested for chemical product, tested for many millions of times. So we can guarantee it's safety. The safety, and then dimension is 220 mm with exterior diameter 315. 30 meters long, 315 exterior diameter, 550 mm length, the height. And we are also putting paraffin wax, which is this one. We are using the paraffin wax as well. The paraffin we're using is 58/60. That one is the purity level for the paraffin wax. And then put into a steel cylinder with a length of 41 cm. And then that's the chemical probabilities of paraffin wax, which the melting point is 47 to 64 Celsius. And then with a density of 0.9 and a specific capacity of 2.14 to 2.9 joule per gram. And this is how it look like. This is a heat storage tank. This is paraffin wax. This is how we melt the paraffin wax before we fill it into the cylinder, the steel cylinder. Okay, now we are talking about the solar collector. For our solar collector, we are using a class 6 class 6 UPVC pipe, which is made in Malaysia, and then it's a diameter of 50 mm, thickness of 2.1 mm, and then we have 4 positions vertically, 2 positions horizontally. So the rough area is around 1 × 1 meter cube, 1 meter square. And then for the solar collector, our testing method is following by ISO WD 9806/1. We're using that standard, which is published in 2010. It's an ISO standard for the test method of solar collector in the whole world. So, and the water flow is pumped by 2 aquarium pumps. So this is how the solar collector look like, and this is piping. So we are using this as a PVC pipe to connect the unit together, and we have the aquarium pump, which is run by AC 240 volt with a power rated at 35 volt from China. And this is the PVC pipe, this is pump, water inlet, bath, and this is the copper rod I mentioned just now. And we have done several testing before, and one is the water flow velocity. We tried to test it, the water flow velocity from the PVC tube to the copper coil. The copper coil is around 15 meter long, right? So by doing 3 testing, we found that the volumetric flow rate is around 16.9 milliliter per second. So the water flow velocity, after we do some calculation, you transfer it to velocity, you find it 0.24 meter per second, which is efficient enough to pump the water through the whole unit. So it's very important. And later on, we will investigate whether it's laminar flow, turbulent flow, and then the transition period of it to prove that to find the efficiency, the heat exchange efficiency. So this is a setup of the whole thing, from the pump through the PVC tube to the coil. And this is a solar installation we have tested in Taylor's in front of that, in Taylor. And so on 20th of February, we have using a software, it's a pyranometer, handphone pyranometer. We use it to test the solar installation we have in this location, and then we found that the highest is 1,200, and then the lowest is at 5 p.m. 546, and then the ambient temperature doesn't have much changes. So based on this data, we can prove that this device can be worked because we have a very high solar installation. So I would like to have a special thanks to our supervisor, Dr. Chong Chin-Hua, and all my teammates, Andy Tang, Sekion, Ken, Chong Jack, and Xiao Wei. Thank you for your time.
What do you dryer? What dryer?
This is the tray dryer saw. Okay, I'm still answer the question. Okay, what you can dry with a tray dryer, right? Actually, it depends on different model. By a simple modification, you can